So good afternoon, and thank you so much for joining us at another event in our Scientists and Strategists series. We're delighted to have you with us today. Today, we're privileged to have two outstanding individuals who embody this intersection of science and strategy. First, we have Dr. T.X. Hammes, a true pioneer and leader in the realm of military strategy, future conflict, and insurgency. Dr. Hammes is Distinguished Fellow at the National Defense University's Center for Strategic Research in Washington, D.C. His academic journey took him from the U.S. Naval Academy to Oxford University, where he earned both a master's in historical research and a DPhil in modern history. With over 30 years of service in the U.S. Marine Corps, including command positions in intelligence battalions and specialized response forces, Dr. Hammes has firsthand experience in key global conflicts, including in Somalia and Iraq. His extensive military background has provided him with unique insights into the future of warfare, which is our topic today. In addition to his military service, Dr. Hammes is the author of influential and, frankly, very famous works, including The Sling and the Stone and Deglobalization and International Security. The Sling and the Stone, which was published in 2004, was actually declared a classic by the top military journal 2 years later. It's incredible. As an author, I'm so envious. Anyway, really a famous book. You must read it. Much of what we're experiencing today was predicted in The Sling and the Stone. Last year, he also published an article entitled "Autonomous Weapons Are the Moral Choice," which promises to be a very compelling topic for us to grapple with on our panel today. We're truly fortunate to have a strategist with such depth of experience and knowledge joining us here in Pittsburgh this afternoon. Next, we have Dr. Jeff Schneider, a leading figure in the field of machine learning. As a research professor at the Robotics Institute here at Carnegie Mellon University, Dr. Schneider has spent over 2 decades pushing the boundaries of autonomous systems, and his work continues to shape the present and the future of the field. Dr. Schneider's contributions go well beyond academia. He was an integral part of Uber's Advanced Technologies Group, where he helped pave the way for its self-driving car program in Pittsburgh, building on CMU's long-standing involvement with this technology. And by the way, this is something I did not know, but maybe you do. Way back in 1995, our university sent a driverless car from here to California. 1995, guys. I mean, talk about a cutting-edge play. Up until then, it was the longest continuous test for an autonomous vehicle in a real-world environment. Hooray! Dr. Schneider also served as Chief Informatics Officer at Psychogenics, using AI to revolutionize drug discovery. Additionally, he co-founded Shenley Park Research, a company dedicated to bringing new machine learning algorithms to industry. His work demonstrates the practical applications and impact of cutting-edge and creative research. I couldn't be more excited about what we'll be able to learn from both of these two gentlemen today. Since we have 2 speakers, we'll start with Dr. Hammes, who will give a short introduction about his background and current work, and then he'll be followed by Dr. Schneider. And then after that, we'll sit down for a longer panel discussion between our scientists and our strategists, finishing with a short period of audience Q&A. So please join me in welcoming Dr. T.X. Hammes and Dr. Jeff Schneider.
Well, thank you very much for the kind introduction and for the invitation here. I'm going to show a pretty rapid trip through the slides. A lot of pictures, in case there's an English major in the room. I'm going to talk about the changing character of warfare. Whoops, maybe. Okay, we had this working several minutes ago, and now we're not. Let me try this. Okay, standard DoD disclaimer. Not part of the National Defense University or DoD, and you'll see why as the talk continues. First, let's make a distinction. I'm talking about the character of warfare. The nature of war, what it is, will never change. It's fog, it's friction, it's uncertainty because there are people involved. You will never take friction out of people. But the character of warfare, how it is fought, changes continually. So we've got to ask ourselves, why does that happen? Well, most of this talk will be about the technology, but the fact of the matter is it's really economic, political, and social conditions of the societies in conflict that measure it. For instance, the German army at the beginning of World War II had figured out all of the technology to fight blitzkrieg and had transformed 10% of their army. But all the way through 1945, the great mass of the German army was horse-drawn. Why? Because they didn't have the economic and social conditions to build a mass mechanized army. So they had to fight with what they had, and that'll be characteristic. Starting with the regular warfare, insurgencies, terrorism, etc., long-range precision strike is present now for the first time, and swarms. And this changes everything, because now instead of having big bases like Bagram, you can't have those because you can't defend them. A huge cost advantage for the insurgent. They're throwing $100 drones at $1 million airplanes, or $100 million airplanes, and it altered global shipping. The Houthi, kind of an 8th century society, have shut down the Red Sea to a large degree. The convergence of all these technologies, the AI, the robotics, and all these things favor the insurgent because they don't have anything to have to protect. They have little infrastructure. We have to protect everything, so we're at a disadvantage. And it's a powerful role for outside sponsors. Back in the 80s, when insurgents were the good guys, I was helping Afghans try to kill Russian airplanes at Bagram. 2-year project, we finally killed 2. Today, it would be really easy. Just get a bunch of drones, give them to them, and they'd be shooting up Bagram pretty fast. Good thing we got out of there when we did. Now, here's some demonstrations. This is a long-range strike Saudi oil facility. The Houthis hit this facility, dropped 30% production. In these 11 places, there are 8 hits on those tanks, almost all at the same position from long range. Upper left is a much simpler process. This was Russian separatists going after Ukrainian ammo dumps. All they did is put 2 thermite grenades, a World War II weapon, under a cheap drone, flew it over and dropped it. That ignited secondaries. They did this 5 times. They killed 250,000 tons of Ukrainian ammunition. That's why the Ukrainians were so short of ammo at the start of this thing. Now, terrorists can do it too. Oklahoma City, 1995, 3 tons in a truck. That was Timothy McVeigh. You don't have to be very smart to do this. If you've seen the interview with Tim McVeigh, it's kind of like the roadshow from Deliverance. He just doesn't really grasp things, but he did that. Beirut port, this is a kiloton level explosion. Texas City, these were just ammonium nitrate storage that were detonated by accident. If it can be detonated by accident, it can be detonated intentionally. We still store that in those quantities, except when we ship it. That ship that's off the British coast now, 20,000 tons of ammonium nitrate, so 1.5 times the size of Hiroshima. Now, the first thing, I went too fast. The 3 major changes in conventional warfare are pervasive surveillance. You can see anything 24 hours a day, no matter what the weather. Mass with precision. We developed precision in the 80s to defeat Soviet mass. But the problem now is all those things that we needed for precision are cheap now because you wanted cell phones. So your accelerometer, your GPS, your cameras are all cheap. And the third thing is the command and control that brings them together. So pervasive surveillance is satellites, it's drones, it's balloons, it's ground sensors. But just take a quick look at satellites. Currently 10,000 satellites in orbit, roughly. Planet Lab will look at Ukraine 10 times a day and sell them imagery. This is a battle damage assessment and visual. They launched these, and a day later, this was published online and in public forums, so probably in a matter of a couple hours, Ukrainians knew. This is synthetic aperture radar, which means you can see through clouds. And you only have these blurry pictures. Wouldn't mean anything to a human analyst, but you apply AI, they identify the specific class of ship. So not only can't you hide under the weather, you can't even hide who you are. So that's coming fast. On precision attack, drones have been the thing everybody's read about most. The upper left is a cheap drone they built. They took a cheap quadcopter and either put an old artillery shell or an RPG round, rocket-propelled grenade round, and now you've got a $400 weapon that kills a multi-million-dollar tank at 6 miles. The tank can't shoot back till it gets within 2 miles. So you got a huge advantage. This is what they've advanced to in only 2 years. They're now putting out a jet-powered drone that will fly 430 miles with precision. And then, of course, this is an interesting variation of that. They have figured out how to trail thermite from the bottom of one of these drones. That S form, that's them dropping thermite on a Russian trench line. Really nasty weapon system and dirt cheap. Cheap attack drones. Didn't come up. Let's try again. The Chinese are really good at this. They took the Shahed, which was an Iranian drone, and improved it to the Sunflower, 1,100 nautical miles, about 100,000 apiece. It has twice the range of the F-35. So you can launch from twice as far. It's a vertical launch, so there's no airfield. You can see they put about 10 of them in the back of this short bed truck. They're fully autonomous. They use what the old TLAMs used, Tomahawk Land Attack. It's a visual picture compared to map data. And it's precision without any need to communicate with a base station or a satellite. Now, why this is important is because one of the big things that makes you obsolete is range. This is the range of the F-35 today, about 600 miles unrefueled. These are a small selection of the drones and missiles that outrange it. And range is what kills you. Any battleship can kill any carrier if it could just get close enough. But the carriers insist on killing it at several hundred miles. Now you can kill the airplanes long before the airplanes are within range. You kill them on the ground. And the real problem is the F-35 cost per lifetime is $1.35 billion. That is not a typo, that's billion. I'm happy in discussion period to tell you how I got that number. It's all government figures. Rapid evolution, they're really fast at this. Ukraine built this boat in about 3 months. They didn't have a drone before the war started. You see the duct tape and everything. Less than 6 months later, they've got this one in the water. They have now dominated the Black Sea without having a navy. This is their ground effort. They're newer. This one is actually in combat now. And the ground environment's an incredibly complex environment. The professor's going to talk about that next. Now, what's even more dangerous is you containerize all these weapon systems. That's a U.S. Navy launch system for a Tomahawk missile, 1,500 kilometers. This is a drone that can be launched out of a 40-foot container, 3,000 miles. So any ship or any truck can now be used to provide a platform for a weapon which can strike out to 3,000 miles. And why do you want it? It could hide in plain sight. The Russians have been selling this for about 15 years. With that container closed, it looks like a 20-foot container. It's not on your priority target list. Then the lid comes up, and in 10 minutes, 4 missiles are away, and you're shooting in an empty container. This is missiles being dropped out of the back of a C-130 or any cargo plane or even a large helicopter with a ramp. And in that is the Iranians just proven that they too can launch missiles from a ship at sea, a containerized ship. It means that any merchant ship out there is potentially carrying long-range missiles. So this is a happy talk so far, huh? Okay, I somehow jumped ahead. We'll just go to this. So what does it mean? Defense dominates. Why? Well, because if you're on the offense, you move. By definition, you have to move. And therefore, you create a signature. And with pervasive surveillance, I'll see you and be able to target you. You have to travel through a choke point. There will be a river crossing. There will be a mountain pass. There will be some region you have to cross. A beach you have to cross. Ships will have to go through a strait or some narrows. Airplanes have to return to an air base. So you're concentrated. And your logistics are very vulnerable. Now, on the defense, I don't have to make any signature at all. If I get overhead cover, either underground or in a building, you can't see me, as long as I don't emit anything. And I don't have to emit because I'm using passive surveillance. And then I can mass attack, decide when to attack, and fire, and my weapons can be distributed in an arc at the range of my weapons. You're in a narrow pass, I'm firing hundreds of weapons from hundreds of miles away. Huge advantage for the defense. That's good news for us, because geography favors the West. Geography favors defense. In both Europe and Asia, we're on the defense. They have to come to us, mixed bag in the Middle East. Smaller states or non-states can now deny major powers, as we're seeing with the Houthis really raising hell in the Red Sea. Allies can make contributions. We keep trying to sell the Allies F-35s, which is a god-awful expensive platform that doesn't work particularly well. Instead, they could buy hundreds or even thousands of these drones and contribute. Mass production returns. This is what we're struggling with here. To give you an idea, the Ukrainians produced 200,000 long-range drones this year and 800,000 short-range drones. Next year, the plan is 2 million. That may mean national mobilization required, not for frontline service, but somebody's got to put these boxes in place. And so they're going to have to do. Look forward to the discussion.
Okay, great. So now I'm going to talk about a robotics and AI project for defense that we're doing right here at CMU. So I'm going to tell you a little bit about a specific project, and then I'll give some comments on the use cases at the end there. For those of you that don't know, The Army's AI Integration Center is about 150 Army personnel that's located right here in Bakery Square. They work very closely with CMU and on education programs, on their own internal development, and they fund research projects here. And I'm going to show you the largest of those research projects. And so this is called ATR MCAS. What it is a multi-robot autonomous reconnaissance system. So these are the ground vehicles. We've got 4 of these all together. These are the drones we use. A little hard to tell from the picture, but they're pretty good size. They're about this wingspan. So how do we use these things? This is the concept here. The operator is going to designate some area that they would like to search, and they'll tag the robots, and the robots will all go off and do that. They'll be fully autonomous at that point. They'll decide where to go, how to get there, what to look at, what's worth reporting back, and then where to go after that. That comes back to some user interface. For those of you that have heard of ATAC before, we use ATAC as the user interface for this. And this might be sitting somewhere in a tent. It might be riding around in vehicles. In practice, there's lots of these tablets connected to the system. This is another view of the same thing I just showed you, but it allows me to point out a couple of things. So usually it would be a tablet, not a cell phone, but could be a cell phone. The operator would indicate the zone on this, and I'll show you what this looks like in the video coming up. They tag the robots. After that, all the compute's at the edge. We don't count on comms because in the environments these will be in, you can't count on comms. So we need algorithms that will operate without them. When things are found, they'll be transmitted back over what we have to assume is low bandwidth, intermittent, unreliable network. So we transmit back something very, very small. Just a few data points. Where is it? What time did you see it? What's your confidence? And here's a thumbnail if we can afford to report that. So this is not like the first-person video that you see all the time now. Once that comes back, you populate the common operating picture, and the commander at that point would choose some kind of follow-up action if they want to see more of it or move around or whatever. I have mostly told you what it's done, not how it's done it, but I want to just make one comment about deploying AI systems. So these systems, of course, there's machine learning models through the whole system. They learn how to recognize objects, they learn how to drive, they learn their strategy for where to move around. And so what that means is you've got to have a method to manage all the data that goes into that training and all the models that come out of that training. And it has to be fast, because what happens, we sit here at CMU and train all these models, and then you take it out to a desert somewhere, and guess what? There's a bunch of things in the desert that weren't in your data, and they're throwing up false positives everywhere. And by the way, your adversary put out a bunch of things in the desert that matter to you that also weren't in your training data. And so you've got to do something about that, and you've got to do something fast. And so a big part of our research here has been figuring out how to make that pipeline work on site in the desert. And also the question, and this is where I lean back on my experience at Uber and self-driving cars, because when we had 2 builds a day at Uber, and they would go to the track, and you'd get a report card back before you sent it to the track from your regression testing. And what happens in your report card? Well, half the things went up and half the things went down. So should you take it or not? And so that's one of the problems we have to solve here. Okay, I'm going to jump over just to a few comments here. Hey, when should we use these things anyway? Most of us know these things, but it's important to think about them when we're doing deployments, because as technologists, we tend to just want to put cool stuff out there. But there actually has to be a reason, or it doesn't make any sense. And we know these already, right? We send robots where soldiers cannot go or do not want to go. We do it where robots can make better and faster decisions, like many like base defense, that kind of thing, have to be that way, because there's no way a human could respond in time. And this is the one that I focus most on, is scale. Many of the problems, you just heard about the issues of the balance of offense and defense. Many of the problems we're experiencing are not that we couldn't defend, but the tools we need to do the many of the tools that we need to do our operations require humans. And so we're limited just by how many people we have. And that's why you have to get the robot to operator ratio much higher in order to scale as the kind of conflict evolves. So a couple questions about teaming. People talk about this all the time. There's a lot of angst about autonomy, the ethics of it, how are we going to deploy this? And we're familiar with these things, right? The ATR, but my point here is the ATR MCAS system, it's not one of these, it's all of them, right? So human out of the loop. The low-level autonomy is human out of the loop. They're not asking for permission, they're not anything. They've been given a zone, they can drive wherever they want. They're not going to ask for help. Human on the loop, yeah, that's happening too, because their mission set, the human can watch them, and if it turns out this is just not going well or not useful, they can be redirected. And then human in the loop, of course, is the follow-ups. If something is detected, what are you going to do about it? They're not deciding that autonomously. That's where the human's going to get involved and decide that. So my last slide here, just to mention, so this system, we've built this here at CMU. We've deployed this in what the Army calls a campaign of experimentation. So their troops have gone out and just tested the system. We've demonstrated that it can find occluded targets at great standoff. We've done up to 8 kilometers. Since we did that test, we've put Starlink on it. It's got unlimited range now. The user interface is hugely important because when you give a cool toy I'll say to a soldier, but you give a cool toy to anyone, they want to play with it, right? They immediately say, "Oh, no, I want that one's got to go over there. I want you guys," and that's not the point. Remember, robot to operator ratio, right? We need to take minimal input from them and then have them go back to do all the other tasks that are important to them and let the robots do what they're good at. But that doesn't happen unless you get the user interface right, so that they have the confidence that everything's fine and the confidence that they can check in and get the right answer about whether it's fine. Obviously, without the human on board, robustness of the platform is important. And then that, again, these are these are obvious, but robot TTPs matter, right? The first thing everybody wants to do is say, well, you know, I've got this infantry platoon, and now you're a platoon with robots. But that doesn't make sense, right? You're going to want to reconfigure the units in your force and how they operate. Okay, so I'll stop there.
All right. So really stimulating. I wish we could have given you more time. We wanted to have time for you to talk to each other too, but I had about 16 questions for each of you. So we're going to get to some of that. One of the advantages of being the lucky moderator here is that I get to ask a few of these questions. But let me start with you, TX, because you started today too. You wrote the Sling in the Stone and published it in 2004, and you had a lot of very creative ideas about where warfare was going, including the strength of insurgents, and you foresaw a lot of developments in robotics and in the relative relationship of power between non-state actors and state actors. What has happened that has completely surprised you?
I think the speed. As early as 2014, I was writing about small, smart, many revolution. And I said, there'll be thousands of drones. It never occurred to me there would be millions of drones. I just didn't think there was a productive capability. I knew autonomy was coming. It's happening in Ukraine today. And you use the term human out of the loop. I prefer human starts the loop. Because there's always a human in this. You program it, you determine where it's going, tell it what to hunt. So it's not like there's no humans involved until Skynet takes over. So the autonomy and the number has been the surprising thing. And the ability to reach out on the ground. The ground environment is so complex, I thought it would be years before they could master that, but they're using it today. Mm-hmm.
What has surprised you, Jeff, in the last 20 years or so?
Lots of things have surprised me. ChatGPT. No, actually, one of the things that surprised me is when we first started this project, we went out to see some exercises, some training exercises, and we were just riding around in the desert watching the troops training there. And they would take us to the different talks for like a battalion level talk or a brigade level talk. And I was puzzled, even at that time, like it's just a pile of tents all there in the middle, and you can see it from, infinitely far away. I'm like, what are these guys doing? Just shoot at the tents. Like what? This isn't hard. So it surprised me that it's actually taken the war in Ukraine for people to say, oh, I don't see why they weren't saying that quite a while ago, but maybe you already were.
Well, I think that's interesting. When I came in 1975, just after the Vietnam War, the CPs were huge, 5 huge tents. Why? Because the Vietnamese couldn't shoot at you. You were safe. Then we started to think about fighting the North Koreans who have multiple rocket launchers which can saturate a grid square. So we went from 5 huge tents at the regiment to a single pickup with our radios in the pickup and a tent that you draped over it. So we could in place in 10 minutes, displace in about 6 minutes, and be almost totally invisible. It's a matter of the threat driving it. Now, the reluctance to change it, again, all the big guys were trained in Iraq and Afghanistan where big CPs were useful. Lots and lots of screens, lots and lots of information flow, and not a threat.
Can you explain what a CP is?
A command post. It's in there. You have the commanding officer is in a position where the different staff sections, like S2 is his intelligence section, S3 is operations, S4 is logistics, S1 is personnel. They paint the picture of the battlefield for him. Then he's got his fire support agencies there, so he can see, understand, hopefully understand, and then decide what to do very quickly. Because you're controlling units scattered over a wide area. In Afghanistan, particularly, they were scattered over maybe hundreds of miles. So the big CP was useful. When the enemy gets the vote to bite back, you got to change.
Jeff, one thing that occurred to me while you were giving your presentation was that so many of the practical sort of testing happened in desert conditions. But also for the last 20 years, we've been talking about how warfare is becoming far more urban. I mean, partly because the world is more urban.
Right.
I always think that's kind of a no-brainer. If most of the world is now built up as cities, it's probably likely you're going to have your war close to a city. So how are your systems going to work when you don't have, desert conditions? And it's definitely, I mean, those robots were definitely going over some pretty tough terrain, but not as tough as if you're in narrow cities in, by the way, someplace like Lebanon or, Sudan, or how's that going to work?
Yeah, exactly. I think what we're seeing here is really mirroring what you see with self-driving cars, right? Like we saw this already, right? When the first self-driving cars came out, where did they drive, right? They went to Phoenix, where there were these giant grids in the desert where it never rains, and because that's the easiest place to drive. And then over time, they've been expanding to other places. And I think we're seeing the same thing with the robots, that the urban areas are going to be the hardest and last places for these to go. Now, people are working on it, right? They're definitely doing this as a research problem. But, if we just look at where we are, robots like the ones we have here, at least for that terrain, they should be out there now. I mean, they're ready to go. But the research to get around buildings, in buildings, not that people aren't working on it, not that you can't see demos. Certainly, if you go online, you will. But the robustness that you can send it off, and it'll wander around an urban area and in and out of buildings, and it's not going to get itself stuck. It's just not there yet. So I think it's just in the sequence of things we work on in terms of developing autonomy.
Yeah, you'll notice that autonomy starts first in the air. It's a very simple environment. Good thing, pilots are fairly simple people. So you have a simple environment there, and then you move to sea, surface of the sea, which can be wildly dangerous, but we're doing more inland seas. Then you move undersea, and ground are equally difficult. Undersea because of the communication problems, all sorts of things. And ground because it's not just the building. Remember, there's people in those buildings who see wheeled vehicles and know to stack stuff in the way. So you have to have articulated robots that can climb over piles of debris. This is why infantrymen do most of the fighting in cities, because people have evolved to climb over things. And so I think that's a huge thing, and it will evolve over time, but it will be not just AI, it will also be the mechanical ability to move. Can you scale the outside of a building? Can you deal with steps? Suppose somebody blows up the steps, how do you get up? All of those sorts of things are an inherent part of being an infantryman. And that was, when I had infantry town, that was one of my toughest things, was training for urban environment. It's just an incredibly difficult environment. And the other thing is, you don't like us running around your city shooting at things. So it's hard to find a place to train. The desert, lots of desert, nobody cares what we do out there. But you move into urban areas, and we build these little cities that are a couple blocks by a couple blocks, which is not even the beginning of a challenge. You can do things like put everybody in civilian clothes and you walk through a city. As long as you don't get caught, you're okay. But sometimes the locals get really upset. What are you doing training in my city? So civilian clothes and don't act like you're military.
How about tunnels?
Tunnels are a whole different order of magnitude. Remember I said you can get underground, get overhead cover, and that's the thing that stops surveillance. The Israelis are probably the best in the world at getting things down, robots and things into the tunnel to find them, ground penetrating radar, etc. But again, there's simple things you can do to stop a robot. Same thing the Vietnamese did to stop us in Vietnam. You dig a tunnel, you go down in a U, you fill the U with water. So whether it's a robot or a person coming up, they're trying to clear their vision and you shoot them.
Yeah, I should make a little ad for some of my colleagues in robotics who work exactly on that, on the challenges of tunnels, of small robots going through tunnels. You don't have the same GPS you have otherwise. Depending on the environment, you may even have to drop communication links along the way as you go. So that's something that's worked on. I should also mention, when you mention cities, this is a while ago now, but if anyone remembers, the DARPA Grand Challenge was something to have a robot that would, it was the Fukushima Grand Challenge, so it was more for buildings that happened to be, nuclear power plants, but even then, CMU had, I think, the only actually autonomous robot doing that challenge. Most of them were teleoperated. But it was one of the earliest examples of digging your way through buildings, figuring out how to open doors, jump in the golf cart and drive it, and it was a great early example of that.
And aren't robots that work in tunnels very important to mining? Isn't that another way that they're being used, particularly in Australia, if I recall?
Right, exactly. And again, where you're seeing, I'll do some more CMU ads here. Some of the earliest mining robots, by the way, were the Caterpillar ones. That the huge trucks that drive around mines, and those were automated in partnership with CMU here, and they now sell those all over the world. So they drive around mines with no driver in.
And this is one of the things about technology. The closest period we have is between World War I and World War II, and the technology is not coming out of military labs; it's coming out of civilians, and for that. And so we're learning to deal with mines for civilian purposes. Then when you go to the military, you got to figure out, how do I do mines where somebody's trying to kill me? Because the mine will kill you, but not actively try to kill you. And so I think that's the transition. You take and build on the civilian, and that's where all the advances are coming in. All this AI and technology is coming out of civilian. We have to figure out how to adapt it, which is what your group is doing so well here, trying to connect the people who can know how to make it work with the people who have to work with it.
Okay, well, you talked about in the loop, on the loop, what the human role is. And it certainly made sense to me that humans were in on, and that made sense in the presentation that you gave. But the real issue that people worry about is targeting, not reconnaissance.
Right.
So any thoughts about in-on human involvement in that?
Yeah, I think it's actually it's really the same. So what happens, it was buried in the dense text on my slide there, but even when I said human out of the loop, which is what I said for our system is what happens with the low-level autonomy. It can drive around wherever it wants, and that's fine. That is authorized within a bounded time and space, and that's what happens. And so the same thing is going to happen with targeting and firing. And I think it would be helpful. There's a lot of times when the ethics of autonomous fire comes up, people just want to debate that top level question, like should it be allowed or not? Well, it's not really that kind of binary decision. It would be much more helpful if people would focus more on developing what's the authorization mechanism. This is very well defined in the armed forces when traditionally You know what level of rank you need to authorize what kind of action for what kind of period of time, right? It's very developed over a long history. What we need to do is figure out what are going to be the authorization mechanisms. Some of this will be just figuring out the policy, but other will literally just be what are the IT methods of doing authorization, of saying this particular piece of equipment is authorized to make that decision for this amount of time and within this amount of space. I think we really need to put more effort on how that happens.
I think what's interesting is we've had fully autonomous lethal weapons for at least 70 years, and we've been using them to kill people. So we're a little bit pregnant, or we're 8.5 months pregnant, arguing about whether we should have a baby or not. It's way too late. We're there. Now, what do I mean? Any heat-seeking missile, when it leaves the rail, is with the parameters established, right, seeking the signature it wants. If it gets a better signature, it'll go get it. We've had smart torpedoes left in the water that if a Soviet submarine comes within range, they activate and go hunt it without any further decision. So a human should be in the loop if you have time. Absolutely. If you're going to kill another human being and you have the time to consider it, like you're hunting an individual terrorist or that type of thing. And that's the problem. Most of our discussion is still based on hunting terrorists. And do I kill that terrorist if I might kill 2 of his family, or that argument? That should be a human with lawyers and ethicists involved. But when you're at a high-speed thing, then you go to something called Aegis Special, which is when you turn the robo-cruiser on and it just starts taking targets because there's too many inbound and you're just going to kill your own crew. And the moral issue that's obviously overlooked is I think there's a high moral value to keeping our people alive. We're always discussing, you might accidentally kill one of them. They are trying to kill us. So the most immoral decision you can make is to decide not to use autonomy and go to war when you know you're going to lose. What's more immoral than deciding to start a war or be in a war that you've already agreed you're going to lose? Then just negotiate to start with and get over it.
Doesn't it matter what the nature of the enemy is, though? I mean, if you're talking about insurgents and decisions about targeting,
when you have time.
Right.
And insurgents is usually a slow developing, except like you mentioned, base defense. Mm-hmm. If you've got your robot set up around base defense and they pop up and are coming at you, then the robot should be able to make the decision. But there's also time there because it's a physical movement. So if it's infantry or something like that, you'll have time. It'll be able to alert the operator will make the decision. If it's an inbound missile, it'll go automatic. And that's the same thing, because as part of Aegis, you have standard operating procedures, you have training for the crew, you have specific rules of engagement depending on which theater you're operating in, and the personality of the captain and his crew. All those things blend together, so it's a human starts the loop. But that's the most likely way to get an ethical and legal outcome, is to think it through in advance, have all the things ready so that when it happens, you're ready to defend yourself. And again, if you have time, absolutely, a human should be in that loop. Not in the loop, actually controlling. Nothing can kill until I say yes.
Okay, well, I'm going to be the devil's advocate here, because I think there are, Joe Smith on the street is going to be asking, if you simply worry about situations where you're in a relatively advantaged position with respect to an insurgent in order to use a weapon, or to a weaker enemy, that's fairly easy. I mean, easy in the sense that you can put your ethical standards in, you can use your bureaucratic processes. Those things are obviously needing to happen even more than they are, but to some degree they were in place even during the use of drones in the last 20 years. But when we're talking about 2 peer competitors, Joe Smith on the street, or Jill Smith on the street, is going to say, these things are going to get out of control. This is the popular movie picture, so I'm presenting that to you, but argue against it. Why is it that we're not going to immediately go into escalation between the United States and name your peer competitor, and therefore have the whole war become no longer human, but now completely controlled by 2 machines?
Again, it's human starts the loop. The human set the parameters. The human makes a decision when to flip the switch and go in auto special, and then when to back off of auto special. If I've dealt with the wave of incoming missiles, I step it back down, and then I get the search out and looking for other things. It's going to be a matter which needs to be war gamed extensively, simulated extensively, and trained extensively so that you really can develop this. because it won't be fully auto. Like all combat, it'll come kind of in waves. Everybody launches the first wave, the robots fight each other, there's a pause, do you do it again? You can't sustain this continually because you got to reload your boxes. And so there's been pauses throughout warfare. It'll surge, it'll be a pause, it'll surge, it'll be a pause. The key problem is don't lose at the beginning. I mean, that's kind of immoral to decide you're going to lose right up front. You're going to get a lot of your people killed for no purpose at all.
You want to add anything, Jeff?
Yeah, I agree. I'm not, well, not concerned is the wrong word, but the out of control escalation, that's not going to happen as long as you do exactly what you were describing, right? A person is deciding at each stage, all right, how much leeway am I giving the systems for the next period of time? And so that escalation might happen, but it would be a decision to escalate by the people involved, the same way that it happens in current conflicts.
Well, we've talked a lot about the use of drones and autonomy and various types of weapons. Incredibly interesting in Ukraine. But any comments about how they're being used in slightly different environments like Israel, Hamas, Hezbollah, and or Sudan, or name your conflict?
Yeah, the Israeli conflict is particularly tough because of the tremendous number of people who were killed right off, and then Israel responded very rapidly, very hard. And they had 3 programs, had Lavender, the Gospel, and Where's Daddy? So Lavender tracked 30,000 buildings. The Gospel tracked 20,000 individuals that they thought were all connected to Hamas. And then Where's Daddy actually tracks people in real time. And then the computer is ready to target. And Israel has a very robust strike capability. So the targets were queued up. And the people who complained about this were the people making the decisions. They said it happened too fast. We didn't have time to really evaluate because of the push to do it now. And so there's a consideration even among the Israelis that they're saying, maybe we got to slow this down. And this goes back, again, a human started the loop. A human made each decision, do it or don't do it. But they hadn't really trained for that in those kinds of numbers. So when you're striking thousands of targets a day, it puts a different burden on the command and control network that you've got to work out in advance. And so I hope we're taking lessons from that. We don't have anything quite at that level yet, but the Ukrainians are making use of it that way. And so it's obviously doable. And Ralph has great faith that JADC2 is going to work. The Pentagon, who brought you the wonderful computers we use now, is going to make this work.
What's JADC2? Can you explain?
Joint All-Domain Command and Control. The idea is all the sensors tied together all the time to provide the right targeting data to the right person or the right information to make the right decisions.
So the number of targets has actually driven, is this what you're saying? The number of targets has actually driven the evolution of that?
Oh yeah, I mean it will have to, because if you're fighting an enemy like China, there are going to be thousands of objects in the air at one time. No human could possibly keep up. And making a mistake, you lose a ship.
Well, Jeff, you made a tantalizing comment about how we have to actually not just throw robots and other types of systems into existing structures, but we have to actually change the structures in order to adapt to those systems. Mm-hmm. Anything you want to expand on there?
Well, yeah, I think reconnaissance in particular, which is what this system is. It was surprisingly difficult for people to really understand the concept that no, the robots are going to go out there first. And because to a reconnaissance person, that's not how they think. They think I'm farther out there than anyone, right? And to get them out of that mindset, it's just a mental change of thinking. But it gets there once you once they experience it, gets there. It's the usual thing. You need that to change your perspective on things. And just another observation again about how you configure the unit. One of the early, I'll say, victories of this system was one of the units took it out there. They were trying some things with it. They sent the robots first, and the adversary, kind of knew what the game was anyway. They were sort of waiting for them. They took out all the robots as soon as the ref said go. They were basically waiting to fire at them. And the funny thing is they had a bunch of different units side by side where they were all doing the same mission in their lane, but only one of them had the robots. The only ones that achieved their mission were the ones with the robots. Because the adversary revealed all their positions when they took out the robots, and the other ones didn't have that. So it's funny, right? Because you just the different things happen, and it takes some time to think through everything to get the right mindsets.
But I think there's two problems, though. It's not just organizations, culture. There's an anecdote from World War I where just before World War I, the British cavalry got to see airplanes for the first time. And they said, this is a wonderful reconnaissance tool because we can fly hay forward to feed the horses so they can go farther out. Because in their mind, you're supporting the horse. So it's that cultural problem. And when you look at the difference between World War I and World War II, you see, as you move to mechanized units, fewer people, more machines, instead of these mass blocks of humans. But it took 20 years to get there. And there was still great reluctance. In 1942, Marshall had to fire the chief of cavalry because he thought he needed 6 horse cavalry divisions. In 1942, this is after Poland, this is after France. So culture is an even bigger problem than organization. If you can beat the culture, you can then change the organization.
So what has to change in today's culture then?
Well, I think places like this where everybody's now talking about, well, who won? Oh, only the guys with the robots. Well, I guess we better get some robots. And then we better figure out, and if you leave it in the hands of the troops in the field, they will figure out creative ways to use these things that never occurred to you in development. Once you turn it over to the operators, they will surprise you, sometimes in a bad way, but they will work it out. And that's one of the great things about the American Armed Forces. If you turn them loose, they'll really do some creative stuff. Other cultures don't do that well. The Russian culture doesn't innovate well. The North Korean culture doesn't innovate at all. But if you give it to American service people, they'll figure out something.
Or at least the Russian army, I would say.
Yeah, the Russian army. Okay.
I think there's an interesting thing that has to change in the way we think about the assets we put on the battlefield. So, when we first started this project, I used to give people this thought experiment. I said, on one team, I'm going to give you $10 million worth of Abrams tank. That's one. And on the other side, I'm going to give you $10 million worth of soldiers on motorcycles carrying javelins on their back. And I said, who do you think's going to win? And, I forget the math, but that's like 50 people on motorcycles, right? And I think we know who would win that battle. And so then the question is, well, why do we have tanks? Why aren't we? Well, the reason is nobody's going to send people unprotected like that, recklessly like that, right? You just don't do it that way. But now that we have autonomy, if you take that same setup, but take the person off the motorcycle, well, then it's very clear you should do that. And the reason is, this gets back to something you mentioned. You really, if without the person, without the lives involved, it's purely an economic battle. Your job is to find a cheaper bullet to hit a more expensive target, and because the lives are out of the picture. And I think we really need to bring that mentality into the systems we design. So we're really focusing on making sure we're always firing a cheaper bullet at a more expensive target.
This is what Assistant Secretary of Defense Catherine Hicks is trying to do. And the idea is, don't focus on platforms. We're platform centric. It's a carrier, it's a submarine, it's an airplane, it's a tank. It's the weapon that matters now. All the platform used to do is get the weapon close enough to affect another one. Well, the weapons are doing that for themselves now. So lots of cheap weapons instead of platforms. The problem is, platforms have Congress people attached to them. Weapons don't yet. We're getting there, and that's part of this initiative. But it'll be a long haul, because it's also the culture of Congress, which has to get elected.
And also human beings. I mean, you started out talking about the changing character of war and the unchanging nature of war, and the next sentence in that, if you're looking at Clausewitz or any of the great strategists, is all about the role of war being a human endeavor. Mm-hmm. So what happens when we have robots who are replacing humans so that you don't have those lives at risk? And what Jeff had to say about this becoming an economic battle, where does that place the very meaning of what war is?
It's still a fundamental human, because it's still humans controlling the bots. Again, until Skynet's active, we're running the war for our reasons. Now, with the potential is that in the balance of passion, chance, and reason, that the absence of heavy casualties will reduce the presence of passion. Because you do stupid things. Once you take losses, like World War I, by late 1914, it's pretty clear nobody's going anywhere on the Western Front. But it takes them 4 more years to convince themselves, because everybody lost so many people. We can't quit now. But if you just lost 1 million robots, they've lost 1 million robots, you go, yeah, maybe this isn't working.
But you haven't mobilized your population either, so you could have no support for the military.
Yeah, and then that depends upon, in a democracy, should we go to war if there's no support for the population?
Exactly.
So I think that's a positive impact, because passion becomes such an intense part of it that rationality goes out of the way. Like, we lost 13 people at Abbey Gate. Oh, it's horrible, and we've been talking about that for 3 years. It was horrible, but the fact of the matter, to extract that many people from a target like that and only lose 13 people was almost a miracle. Because if the Taliban had at any point said we're done, they could have wiped out hundreds. So, but the passion, we see the families that lost loved ones, and that stimulates passion. And so rationality kind of goes out the window in these discussions.
Well, Jeff, at one point you also talked about the fact that we need to use robots in situations where we don't want to put humans at risk, dirty, dangerous.
Right.
So does that mean that we're going to solve the recruitment problem that the United States has right now by having a lot more people, fewer people and more robots? Because I hear about that all the time from general officers. You know, we got to increase the number of people in the Army. We don't have enough people.
Yeah, they have their version of the thing that we talk about more broadly in society, like, oh my gosh, AI and robots are going to take all the jobs away, and we're all going to be here unemployed and depressed. And that's not the way economics works, right? It's been that way forever. And you go back hundreds of years, 98% of the population was farming. We have enough automation and productivity that it's now, I don't know the number, 1.5%, 2%, something like that. We don't have 98% unemployment. There's always more jobs to be done. And I think even as we take the soldiers maybe off the front line, or they're not directly in harm's way, there's still way more that needs to be done in developing and managing the systems and analyzing the data, all of that thing. There will be more than enough jobs that take the place of the ones that are replaced.
But this concern about lost jobs is also a bit of an if, because that assumes that all of the benefit from this goes to the capital. We reduce laborers, we keep the money in capital. Suppose instead we reduce laborers, so we reduce the labor week. Instead of a 5-day work week, you have a 4-day work week. Now you've created 20% more jobs. But the money doesn't go to the capitalists, it's distributed among the laborers. And that is a political decision.
But I was actually bringing it up as a good thing that people say, that we can actually, have less of a recruitment problem if we can fill those slots in with robots.
I don't think our recruitment needs are going to go down.
Okay. Well, it's your turn. I'd like to hear from the audience. So we have a couple of mics. And before you ask your question, I'd like you to identify yourself, please, and particularly what you're associated with here at Carnegie Mellon. So over here on the right.
Commander Heather Thomas, the Navy Fellow for CMU. My question is, with these robot decision-making trees, how do you think an autocratic versus democratic nation will kind of decide that? And is there a way you can exploit it? Like if we kind of have thoughts of democratic, like, no, let the robots go this far for, this box or this whatever, maybe like this more centralized decision-making might be on the other side.
I think one aspect that's going to be different between an autocratic and a democratic approach is in democracy, where we live in a democracy, we see it, right? We spend a lot of time agonizing over what is going to be our ethical approach and how we're going to make that happen, where an autocratic government has more freedom to just pick something and go. And I think that is one of the risks we have. I think some of our adversaries have just made decisions and went that we haven't yet made. But I think that plays out more on the sort of the political and longer term scale. I think the way that shows through to the actual deployment and operation of units, less clear to me how much difference there would be there.
A lot of it will be in the design of the software and the organization. If it's a flexible organization to go from no autonomy to full autonomy and practices across the range, then you're okay. As far as autocratic versus democratic, remember, we were the people who dehoused the Germans. We were the people who burned 21 major cities in Japan were burned to the ground. We got over ethics pretty fast when it was a matter of survival. And I think the same thing will happen again. Remember, passion, chance, and reason. Reason moves aside when passion gets involved. And Clausewitz made that point, that once passion's involved, it's a whole different game. And so if they're starting to kill large numbers of American soldiers, sailors, and Marines, then there's going to be a passionate response. If they sink a carrier with 5,000 people aboard. If on the other hand, they sink an unmanned ship or a missile merchant with 20 guys aboard, there's a little more room for reason. So it actually, I think robotics can reduce the probability of rapid escalation.
Interesting. Okay, another question? Yes, here with the white shirt.
Sorry, yes, sir. Scott Awesome, the Coast Guard fellow from CMIS. So you're making your way through the fellows. Hi. You talked about the push towards tactical defense. A lot of the technologies and a lot of the policies for these ideas are really designed, I think, for an away game. Could you talk about some of the policy issues or the other challenges that come when ideas and technologies like this are applied in a homeland defense mission within U.S. territory?
Great question from the Coast Guard.
Yeah, there's a couple of problems here. One, we are not in any way prepared to defend the continental United States against cruise missiles. So on that happy note, we'll continue. For instance, if I were the Chinese getting ready to fight the United States, I would pre-position smart mines in all our harbors, and I would have merchant ships full of cruise missiles sitting off the coast. So the war starts when all of your B-21s go away and all of your B-2s go away, because I know where they are. I mean, you can see them from space. So I know where they are, and I know where they are minute to minute. And then your harbors are bottled up, and the war has started with you really on your back foot. So that's what the Homeland Defense thing is. So now what we've got to do is figure out, how do I use autonomous interceptors to solve this problem? For instance, Anduril's got the little drone hunting ones that are fairly cheap, pop up in the air and go hunt things. So those can be set up, and then if your intelligence keys that things are getting bad, you can flip them to a semi-auto mode or even an auto mode. But the good thing is the distance involved, if you have the radars present, or we're now getting good enough to see this from space, you can then flip them to automatic. But we've got to invest in it. And this is one of the problems now. We are spending so much on what I see are fundamentally obsolete platforms. And this is where the Pentagon and I disagree rather strongly. Then we can free up money for these things. Again, one F-35 or 4,500 long-range autonomous drones, which is a bigger problem for the bad guys.
Okay, someone who is perhaps not a fellow in the middle here.
Bobby Norwood, technically not a fellow, but still military because U.S. Army AI scholar. My question, so I actually just came from a reconnaissance unit in the U.S. Army, and obviously the level of technology there is still about 10, 15 years ago. How fast do you think we're actually going to start seeing some of these more advanced, either versions of the same thing you're working on or other AI-enabled tools actually being used for reconnaissance by the military?
Yeah, I think some of the AI-enabled tools are already there. Those of you familiar with the Maven program and what came after that, right? There's a lot of automated processing of sensor data already to help with reconnaissance at various scales. In terms of the system that I showed, it's less of a technology question and more of a organizational question in getting over the valley of death in commercialization, right? It takes a certain commitment and understanding of that process to make it happen. So Yeah, you heard that I was one of the folks that helped Uber start their self-driving car program. And when we started, our goal from day one is we had 18 months to give an autonomous ride to an Uber rider. And we missed by 1 month. And so, and we did not do that by going TRL2, then TRL3, then TRL4. We made a commitment to do it and built the product that needed to be built. And I think Army procurement has not reached the stage where they understand that.
Well,
Not a criticism on the individual level, because many of the individuals understand that, but on an organizational level, they're just not there to execute that.
but there are some bright spots. I mean, this is where Secretary Hicks' replicator program. I mean, yes, we labored mightily. We ended up with 1,000 cheap weapons at only $100,000 a piece. That's the Pentagon thing. But from that, Underill's starting to come out with a lot cheaper things. We're beginning to look at a way to bypass. Now, the most important thing is these aren't being made by the big five contractors. They're being made by people who can do things fast. And they modify things. Like, for instance, Valkyrie, made by Kratos, is a vertical takeoff and landing off a rail jet. The Air Force says, no, it's got to have wheels. No reason it should have wheels, but it's the Air Force. You're going to have wheels. So in a matter of 3 months, they figured out how to build a trolley to launch it off of and reprogrammed it so it could run down the runway on a trolley and then separate and take off. So I guess the Air Force might be happy now. But I think the real problem is it's too cheap. And that's a real problem. Cheap doesn't sell well at the Pentagon. The good news is it's moving over to innovative companies, people who can say, okay, in 18 months, I'm going to do this and just do it. Then the question is, how do you get funding for it? And that's what Replicator did. Congress got behind enough to put up, I think it's $1 billion now, which is kind of small out of a $1 trillion budget, but it's a start. And so I think that's encouraging.
We've been focusing on all the really cool stuff, but what about the boring things that are going to be completely changed by AI and machine learning, like back office procedures and personnel and matching people to the right MO? And, perhaps that'll have an even bigger influence on the future of war, and particularly in the United States. What do you think, Jeff?
Yeah, I'm excited about that use case too. It's a little bit different one than I talked about. But right now, if you look at the job of an intelligence analyst, it's I used to joke their job is to go to work in the morning and read a bunch of memorandums from the previous day, take lunch, and then write a bunch of memorandums. and that's what they do. And so obviously there is no way they have the bandwidth to actually consume all the relevant material there. And so I think as we now have the language models and other ways to do that, I think that would, and I don't know if that qualifies as a boring task or not, but I think we really have the potential to have something where the machine actually reads everything, and the analyst can sit down and say, all right, let's have a conversation about what's important from the last day. And I think that would drastically change that operation.
A great deal of the staff work is busy pencil work, which should all be eliminated. Large language models will be able to handle it. You can then move people to more productive things, which increases your reenlistment rate, because people don't like doing that ridiculous stuff, counting things in warehouses, et cetera. So we can do those sorts of things. That'll be a big difference for this. So all of the back office tasks should be doable. Again, you run into culture. We have a promotion system that's based on the only person that matters when you're working is your boss and your boss's boss. The guy who's least likely to ever see you in person, the more senior you get, is the guy who writes the most important fitness report in your career. That is insanity. We've known this for 50 years. We keep pitching that maybe you need a 360 report. And all the guys at the top go, oh, that's pretty good, I got here.
But what's a 360 report?
A 360 is your subordinates, your peers, and your boss right on you, and then you get an average of those. So anybody who just pleases his boss, the subordinates will know. Anybody who just pleases subordinates, the boss will know he's not doing it right. So it's a mixed score of those. Because frankly, the people who work for you know you much better than the people you work for. It's just a fact of life. And your peers see a different thing. So that would give you an evaluation of the whole person. So we keep saying we want encouragement over warfare, encourage making mistakes, learning by doing, and yet the personnel system is set up to be actively hostile to that. So we have this incredible cultural disconnect between what we say we want and what we actually do.
Other questions? Yes, Jay.
Hi, Jay Aronson. I'm historian, science technology, and society scholar, human rights person. And you actually just kind of taught the class that I teach on drones and autonomous weapons much more efficiently than I did. So thank you for that. My question is that technology is super cool and it does really cool stuff. And you're doing a lot of that work. But wars don't end through technology in most cases. They end politically. And we had a tremendous technological advantage over the Taliban. And we left with our tails kind of between our legs. Yeah. After 20 years, 21 years, 22 years, in Israel and Palestine and Lebanon, Israel is fighting the same wars that it's been fighting for a really long time and has massive superiority. So my question is, when you're developing all of these technologies, are you thinking solely about your proximate mission, or are you thinking about the ultimate goal of peace and conflict resolution? And if you're thinking about that, or not thinking about that, how does developing all of this AI weaponry actually create the conditions for peace and for security around the world? Kind of a complex question.
I started my talk by saying it's economic, political, and social conditions will determine what the technology can or can't do. They also determine what the military can or can't do. I mean, anybody who studied history at all, when we went into Afghanistan, would have said, okay, this is really stupid. I mean, this is world-class stupid. And then anybody who studied the history of insurgency would say you don't win as an outside power coming in and trying to do it. But the political decision, the political anger, again, passion, over 9/11, we went into Afghanistan, and then a political decision was to focus on Iraq for God knows whatever reason. And so we lost focus on Afghanistan. Well, then we started to lose more people in Afghanistan, and so passion kicks back in. And so this is the problem. It is not the technology, it is the political system it operates in. No, we cannot change that. What we can do is give them a tool that if they use it wisely works better, and that's what I'm working toward, if you use it wisely. I can't do anything about the people Americans elect. And through our history, we've got a checkered past in that respect. We tend to elect some people who shouldn't be.
Yeah. I think it's an interesting question you ask because, as you said, it's ultimately a political or social process that really stops the fighting. And so the question we could ask, and as you said, the technology deployed by those folks may not be the thing that stops it at all, but to ask, can AI do anything with that political social process to try to get us to a point where we're ending wars or not fighting them in the first place? I think it's a really interesting question because right now we're seeing the just very limited thing, basically the information wars, using AI and social media to try to shape the opinions to get the outcome you want. What's interesting is can it go beyond that? Could AI actually get involved in whatever negotiation processes, whatever other things happen as part of the political and social means to stop or not start a war? I think it's interesting.
They're actually working on this. Ralph's got a program that does he was explaining to me on terms of trying to create simulations so political leaders can go through sets and reps of all the things that can happen to you. So when it happens to you finally, you're a little more mentally prepared. This is all, political leaders in the United States are elected for domestic reasons, and suddenly they're on a world stage, which they may or may not be ready for in any way. And AI may be able to help with that, particularly as we begin to experiment. But I think that's the critical thing. There are people thinking about this and trying to make it work right here on this campus.
At CMIS.
Yeah.
Okay, other questions? In the back, the young lady with the glasses, please.
Hi, Cody Berger. I'm a senior undergraduate majoring in computer science. One of the things that personally gets to me about the advent of drones over the past few years is just how much damage you can do with something so cheap, and how that can completely change the character of a conflict. And this is something that's kind of been brought up in this discussion. I've also heard the perspective specifically about air defense that, well, sure, maybe you used a unnamed $1 million missile to shoot down a drone, but it served its purpose, and you have to think about it in terms of the lives saved and the mission accomplished. This is not a satisfying explanation for me, and so I was curious to hear your thoughts on the matter.
I think an apology for us going to ever more expensive missile systems. Sure, you spend $1 million missile and you save a $10 million target. The problem is you run out of $1 million missiles, and now all the targets are vulnerable. Whereas if you were shooting $100,000 missiles, you'd have 10 times more. That is the direction we're actually going. And Ares has done it. Anduril is doing it. A number of manufacturers are leaning that way when they see that it's going to be the small, smart, and cheap that will prevail. You'll need some exquisite weapons for certain deep strikes and certain targets, but not as many as we have. And we certainly don't need a uniform Air Force across the board of 2,000 manned aircraft that are incredibly expensive. Is that really a good use? That's the fight we're having now. And the fortunate thing is, unfortunate for the Ukrainians, fortunate for the rest of the world, they're demonstrating this fact. And so we don't have to keep blindly going down the path of ever more expensive. For instance, it's beginning to look like the Air Force has finally accepted a sixth generation fighter may not be a smart idea. An airplane that costs $500 million a piece to get one fighter in the air for a short period of time doesn't make any sense.
And the most effective piece of technology in Afghanistan was the IED.
Yeah, for that. But again, this is where economic, political, and social conditions. The social conditions in Afghanistan is they will fight you to the last person. That's just Afghans. First rule of all military history is leave mountain people alone. They're up there because they want to be up there, whether they're Afghans, Basque, or West Virginians, they're up there. Number two, don't think you can fix another country. Until you fix Baltimore, don't tell me we're going to fix Afghanistan. Okay, enough of a rant.
Okay. I think there was a question sort of towards the front, a hand that went up pretty early. Yes, yours.
Hi, I'm John Pan, CMIS graduate student and second lieutenant in the Air Force. Dr. Snyder's slides talked about the ATR MCAS model, development flow, where at the end of the process, the commander approves the final model. I'm worried that the human component of the kill chain will just be another memo on that pile that's just ever growing. And I'm curious if y'all think that field and company grade commanders are currently qualified to approve the parameters of autonomous weapon systems. If not, what knowledge gaps should we focus on to make informed decisions about these systems?
Yeah, I think that's an interesting question because it's something we're still resolving. How do you, that report card I mentioned where, half the things got better and half the things got worse, what are you supposed to do? We still don't really have the answer to how you handle that one. The answer hasn't been done for self-driving cars, and it certainly hasn't been done for military systems. So I think that's a work in progress. As in terms of the commander having the ability to make that decision, I think that can be, do they have the background today? Maybe not, but that can be trained. It's really just more about understanding the different dimensions you're being evaluated on and what the impacts of those are. I think that will be trained and that'll be fine.
Another question? We're almost out of time. Want to get the last question in? Yes, at the very, very back.
Hi, so I'm Mark Sherman from the SEI, Software Engineering Institute. So Putin is clearly saber rattling with nukes. China's inventing nukes. North Korea and Iran see nukes as their deterrence. I assume you're not a fan of Sentinel. What would you suggest to Commander of Stratcom that he should be doing in order to maintain deterrence in that kind of situation?
Well, I think deterrence counts on if you use it, you're going to go away. And that works both ways, both for them and for us. I think this immediate concern of China is going to have 1,000 nukes it never made sense to me. Back in the Cold War, you'd have these weird discussions about, is 10,000 nukes enough? You're bouncing rubble. If 10 nuclear weapons get through, the United States ceases to function as a society. 10 of our major cities go away. I mean, maybe LA and Dallas we can agree on. The rest of them are a problem. So, trying to make this a not so serious subject, but the fact of the matter is, nuclear weapons change things entirely. Now, I don't think that either Iran or North Korea are suicidal. I don't think Putin is. He keeps drawing red lines. The Ukrainians keep crossing them, and he draws a different red line. I think we're up to 8 or 9 red lines the Ukrainians have crossed. Sentinel might work, but again, let's say that our anti-missile systems work at 95%, and they only launch a small volley of 200. Okay, that's 10 big missiles get through. Again, what 10 cities? So I think it's kind of bizarre to think that you can intercept enough missiles to change this, and is that a good investment? It works in an idea against North Korea because they can only launch a few, and so that makes sense. Same with Iran, although we're facing the wrong way. So it'll be Aegis-class cruisers having to deal with that, and they're going away, so I guess the DDGs do it now. So for that limited deterrence, they're good. For a major power, I think you deter by mutually assured destruction.
So you tell them to go ahead and continue building Sentinel in order to get
Sentinel being the surveillance system?
Sentinel being the replacement of Minuteman.
Oh, God, no. Not unless it's mobile. Because the fact of the matter is, if we know where it is on the ground, we can put a missile within a couple feet of it, and it's going to be nuclear tipped. But again, that would be hundreds to kill our missile fields, but they can't get our submarines yet. So I'm not sure that Sentinel's worth it. If you're going to build a deterrent land base, and you may want to, make it mobile. Now you get the problem of governors don't like nuclear weapons driving around their states. So maybe you have to go to the desert, like you're talking about, moving around the desert. I mean, you blow up large parts of Nevada, and nobody will know.
Okay. Jeff, I can't resist asking you one more question. What is the greatest technological challenge that you personally face in your work right now? What's the thing that you would most love to solve that is a really serious challenge?
I think there's a ton of them, but okay, so I'll pick one. I think the robustness and the verification of that robustness of autonomous systems, it's quite a challenge to get them. Again, same thing that's going on in the self-driving car industry, right? Self-driving cars work. They're great. The only reason we didn't all take them to get here today is that long tail of rare events. It's very hard to solve every last problem and to know whether you've done it or not. And so that's I think that's the thing that from a research point of view, that's the thing my students in my lab work on. It's something we're very interested, because that is the one of the blockers to really deploying these things in more places.
Yeah, I can see that, because you're talking about putting them in war situations where people's lives depend on them.
Right, exactly.
TX, any final comments? You haven't said a word about 3D printing, and that used to be a big topic.
Well, I mean, because we're finally doing it. I mean, that's why we're getting cheap cruise missiles and things. We're beginning to print in so many medium and so well. The aircraft in Europe, the little private aircraft or business aircraft, they started with 855 parts in the engine. There's now 10. It's production. They're starting to sell it. Think of what that does for everything. Everything's 3D printed in, and all these things are coming along. So one of the things I would do is I would start a Civil Reserve Air Fleet type program for advanced manufacturing. And under that system, it used to be in the 1970s and 80s, if an American airline bought an airplane, we paid 15 or 20% of the cost, with the guarantee that if we go to war with the Russians, you turn the airplane and crew over to us, and they're flying troops to Europe. So why don't we buy 15 or 20% of advanced manufacturing facilities? This would build you a constituency within Congress, because this is not just jobs, but great jobs in your area, and moves you into the future. That's what I'd like to see with the 3D printing, but not just 3D printing, advanced manufacturing, so robotics, AI, the whole package.
Excellent. All right. Well, this has been such a fascinating conversation. Thank you to both of you. Shall we thank our guests?
Thank you.
Thank you for coming. See you next time.